To troubleshoot the new EcoBlue ECM indoor fan motor, first observe all safety considerations such as lockout, tagout, and wearing the appropriate personal protective equipment. Switch off the unit disconnect. The EcoBlue indoor fan is powered by an electronically commutated motor and controller. These two components are attached together as one assembly. This assembly is analyzed and serviced as a single piece. No further disassembly or servicing is required. Because the power leads are internally connected to the controller portion, motor lead resistance testing is not applicable. From here on, we will refer to the assembly as the motor. Remove the side panel enclosing the fan section. Confirm the fan can rotate freely and has no obvious mechanical damage or obstruction. If the fan does not spin freely, remove it and determine why. See the fan disassembly video. Visually inspect the plug connector which makes all fan motor electrical connections. Is it snap locked together? Do all wires appear secure and in place? While here, visually inspect the manual reset limit switch connections and the red reset button. If the switch has tripped, there may have been an extreme airflow restriction or an actual fan failure. Remove one of the leads and with an ohm meter, check to see if it is open or closed. If this switch opens, all unit operation would cease as it removes 24-volt AC power to the unit controls. Standing in a safe position, switch the disconnect to on. Whether the motor is three-phase or single-phase, it is wired across the line and should receive power whenever the disconnect is on. Again, we see the plug connector. The bottom shown here has two whips which make the motor connections. Check for the unit line voltage at the power whip. Three-phase motors will have black, yellow, and blue leads with a green-yellow ground wire. Single-phase motors will have black and yellow leads with a green-yellow ground wire. If there is no power, troubleshoot back to the unit terminal block. The motor is not the problem. If line voltage is present, check for 10 volts DC available between the orange and white leads in the other control whip. If the motor is powered, it should always produce this output. If not present, the motor is the problem. If the motor is powered and working, 10 volts DC should be present. The 10 volt DC is delivered to the UCB at the IFM connector. This can be checked at the upper terminal 1 and the lower common spade connector of the fan speed setup controls. When indoor fan operation is required, the UCB will create a DC voltage output at the IFM connector upper terminal 2 and then through the gray wire running to the motor plug connector. If there is a 4 to 10 volt DC signal available at the control whip between the gray and white leads, the motor should operate. If not, the motor is the problem. If no voltage is present, the problem is in the control box and could be the UCB, the IGC, or the thermostat inputs. In review, the motor should be considered the problem only if, when power is available to the motor and it does not create the 10 volt DC output at the control whip, or when power is available to the motor, it creates a 10 volt DC output and a 4 to 10 volt DC input is delivered on the gray lead and it fails to operate. Again, the motor is supplied as an assembly and no further disassembly or testing is to be done.